Okay, hi guys. Today we're going to talk about why is ontological mathematics important in climate science? Is it relevant to us? Is it important for us? And does ontological mathematics even apply to climate science? So why is ontological climate mathematics important? So just to get straight to the point, what we are facing in climate science with climate science policy, because they are not doing ontological mathematics, a logical sequence to a total extinction level event has been created. Okay, so just straight up, just go straight into it. That's what we're facing. Because they've gotten the math wrong, ontologically, they're using ontologically incorrect math as premises, as initial foundational premises in how they approach their understanding of the climate. The consequence of getting that math wrong, because it's not ontological, is they have now developed a logical sequence, following the logic, it's illogical, right? Obviously, but it's following the logic of their flawed initial premises, of their illogical initial premises, right? And it is creating a total extinction level event, engineering one, okay? So how does this logical sequence work? It starts off with the carbon dioxide / greenhouse gas greenhouse effect, which we've probably all heard of a little bit, right? That's where it starts, okay? From there, you get global warming and your climate change crisis, yes? From there, you get global government governing policy, things they want to do about it to solve this crisis, supposed crisis, right? The big thing that they're going to, that they, where it looks like it's all leading to, is that they want to remove sunlight, which they call solar radiation management. So they want to remove sunlight and they want to remove carbon dioxide from the air, out of the air, from the environment. So that's the solution that they have come up with. Remove sunlight and carbon dioxide from the environment in order to fight this climate change crisis because of the greenhouse effect, yes? The problem with this is that this is a potential risk of the foundation of all life, a total extinction level event, because life is fundamentally based and dependent on the sunlight we have and the carbon dioxide that we have, and that's in photosynthesis, right? Great. So we've come up with some very, very risky and dangerous mitigation ideas, proposals to fight what we think is this crisis. Now, is the mitigation proposals, policies of getting rid of sunlight and carbon dioxide worth it to stop the climate from changing? So foundational due diligence. Let's look at the foundations to see if we've really got the science right. We better make sure that we've got it right before proceeding with it, because it's very dangerous to begin engaging in some of these practices because we get them wrong or do them in the wrong way, remove too much sunlight or remove too much carbon dioxide, you can end all life on the planet, a total extinction level event of all surface life on the planet, because almost all surface life is dependent upon photosynthesis, which requires sufficient levels of sunlight and carbon dioxide. Okay, great. So is the cause sufficient to the undertaken risk to mitigate? So cause is the greenhouse effect. This thing called a radiative greenhouse effect, or RGHE, I will abbreviate. It's an effect due to radiation, which just means due to light and infrared light and what they say it's going to do. Yeah. In the next slide, I'll explain some of these points. So the thing about this greenhouse effect, when you look into it, is that it is based on false theoretical and empirical initial premises. It's inconsistent with well-established thermodynamic principles, and it's inconsistent with well-established empirical facts. Okay, and so the point is, again, obviously, that false initial premises lead to incorrect conclusions. So there can be no global warming or climate change due to something which does not exist. So if this greenhouse effect does not exist, and we can prove, and of course this is what my whole video channel has been about demonstrating, that this greenhouse effect does not exist, this radiative greenhouse effect does not exist. So that means that there can be no global warming or climate change due to it, right? So there can be no global warming or climate change due to something which does not exist. And because it does not exist, that means that it's a problem which can never be solved, right? It means you will never solve the problem of climate change through tackling the greenhouse effect, because the greenhouse effect doesn't exist. Now, that also means that the solutions you come up with will not have predictable consequences, will they? Because you're trying to solve a problem that doesn't actually exist. So whatever you're coming up with to solve it, you think it's going to apply to it, but it's not actually going to apply to it because the thing doesn't actually exist. So what's it going to apply to? It's going to apply to nature nonetheless. And what are the consequences going to be, right? The consequences of removing sunlight and carbon dioxide, that's not going to get rid of your greenhouse effect. The unpredictable consequence is that that's going to get rid of all life. In fact, we can predict it here to them, to people who believe in this. It'll be, oh, we didn't predict that, but it'll be like, no, I predicted it. That's actually clearly what's going to happen, right? So the vilification of carbon dioxide is false science. So here is where we have a slide to get into it. So false initial premises lead to false conclusions. So that's what this slide is all showing here. And yeah, I don't think I'm really in the way there of anything. Okay, so false initial premises lead to false conclusions. Okay, so what are the initial premises? Oh, here. So non-ontological mathematics, so that's the same thing. So false initial premises leads to false conclusions. That's the same thing as saying non-ontological mathematics leads to false conclusions. And that's what's happening in here, which I'll explain in a moment. Non-ontological mathematics, and it's leading to false conclusions. Okay, and the consequences of that are potentially fatal and are going to be fatal because if they succeed, as I discussed in my live stream, not too long ago, if they succeed with creating an umbrella out in space to block the sunlight from the Earth, and if they succeed in creating systems that rapidly remove carbon dioxide from the atmosphere, what's the result of that going to be? It's going to be a huge total extinction level event. You're going to kill off all life, right? So what's the initial premises that they're starting with? They're starting with solar input is equal to 1/4 of itself. Now that's a hat tip to Kurt Gödel and the theories of incompleteness, right? That's a pretty incomplete statement, right? Does that statement make sense? The solar input is equal to 1/4 of the solar input, right? That's what they're doing. Where are they doing that? They do that in their energy budget models right here. See that number? See that little equation? See how it has a division by 4 there? Now look at that compared to, and that's on their flat Earth model. Compare that to my spherical Earth model. In my spherical Earth, I just have this F sun, 1370 watts per meter squared, right? They're taking that and they're dividing it by 4. Okay? Why are they dividing it by 4? So they're saying, they're applying this incomplete statement. That's what they're doing. They're saying that the solar input is equal to 1/4 of the solar input. Does that make sense? Or should the solar input be equal to the solar input? Okay, so on my spherical Earth diagram, I have the solar input equal to the solar input. Now that's a consistent statement, right? That's a consistent and complete statement, right? It's tautological. The solar input is equal to the solar input. It's tautological, therefore it's true by default, right? Their statement for solar input is the solar input is equal to 1/4 of the solar input. That's not quite a complete statement, is it, right? But that is their initial premise. That is their initial premises from which they derive the greenhouse effect, right? So the consequence of, so why do they do that? How do they get to this result of solar input is equal to 1/4 of the solar input? That is a consequence of global mathematical surface average output of the Earth being used for the input. Now you see how they have this input right here? This F, that's the flux from the sun, times this 1 minus A over 4. See how that is, they're using that as the input to the Earth? Look what happens if you use a spherical Earth instead. Say they have this flat Earth. If you use a spherical Earth instead, you get that value, but that's just the output of Earth. So the output of Earth is 1/4 as strong as the solar input. That's fine. You wouldn't expect the Earth to be able to emit as strongly as the sun. And of course, there's geometric reasons too. It's because you have a cross section of intercept versus the sphere output, and the sphere is larger surface area, and so that's where that factor of 4 comes from. But that's the output of the Earth, right? That's fine. And that's totally mathematically and geometrically justified. The output of the Earth is 1/4 of the solar input in terms of flux, right? But the solar input is the solar input on this sphere, right? In their flat Earth diagram, their flat Earth approach, they have the solar input is equal to 1/4 of the solar input, which is actually the same thing as just saying that it's the Earth's output being output or being input back onto itself. So it's just backwards, right? They've just basically got it backwards, right? So it's a consequence of global mathematical surface average output being used in the output. But what's the problem with that? That also implies, here's another problem. It implies that Earth has to be a flat plane to be possible. So, because look at this. They're saying that this value, the flux of the sun divided by 4, is a totally evenly distributed input on the surface of the Earth, right? So how could you have the radiation from the sun, the heating from the sun, be a totally uniform input on the whole surface area of the Earth? How's that possible, right? Because we know that the Earth has a day and night, right? We know that there's a an equator where the sun is strongest, and then the sun disappears at dusk or appears at dawn, right? And then at nighttime it's not there at all, right? So there's in reality with a sphere, the spherical input, as the Earth is, we know that the solar input is not uniform, right? But they're using a completely uniform solar input. How can you have a completely uniform solar input on the surface area of the Earth? That would imply that there's suns all around the Earth, surrounding the Earth. Well, if we're not going to say something as stupid as that, and we're still going to assume that the sun is a distant object that's pretty much a point source far away on one side of the Earth, then the only empirically realistic ontological way to get the sun to provide a uniform solar input on the equivalent surface area of the whole surface of the Earth is if that surface area was a flat plane facing the sun. That would be the only way to get it uniform, empirically, ontologically, right? And that is why that input of the solar flux equal to 1/4 of the solar flux, the solar input equal to 1/4 of the solar input, is always depicted with a flat plane, because that's the only way that it would make sense ontologically. So there's internal consistency in how the math of a quarter solar input is being used on a flat plane. Obviously, ontologically, it's not realistic, but that's nevertheless what they do. So due to not empirically, ontologically realistic mathematics and premises. Okay, so their initial premises are incorrect. So this slide just shows a bunch of the differences. In my next video, maybe I'll go into a bit more detail of this. I will have this linked in the description so that you can download this and share it and use it. This is actually a really good weapon to use against them. You just show this to them and it'll make them go bonkers. So there's a whole bunch of differences that come up between using a spherical Earth, as I suggest, versus the flat Earth, which climate science is using to create, this climate alarmism and CO2 vilification. Right? So on the spherical Earth, I mean, if you just work out the details, I'll just tell you what it is. On a spherical Earth, you have the hot sun where it's supposed to be at 1 astronomical unit away. That just means, 150 million kilometers, right? You have direct solar input at 121 degrees Celsius. That is how strong the sun is at the distance of the Earth. You have that the sun will create the climate with that primary forcing of heating. The sun can create the climate with that much power. You can stay consistent with heat flowing from hot to cold only. That's a basic principle of thermodynamics, in thermodynamics. You have a day and night. That's nice, right? Have a day and night. You have a rotating Earth. You would assume that the Earth is rotating there. The adiabatic effect causes the lapse rate. My next video is going to be on that again, and I covered that in the live stream. So that just means that's a temperature distribution, that the air should be hottest near the surface, should have an average temperature around the middle and should be coolest at the top. So there's some really basic simple physics, thermodynamic physics, which you can derive to get that value of how that, what the rate is, what the temperature drop rate is in Kelvin per kilometer or Celsius per kilometer. So the Earth's effective temperature is Earth's output only. So that output of minus 18 degrees Celsius for the Earth's temperature, that, you would not use that as a solar input because it's not the solar input. The solar input is the solar input. The Earth's output is something else. You wouldn't use the Earth's output for the solar input. Why would you do that? You don't have to do that in spherical Earth, but you do in flat Earth. And then, of course, the climate scientists say that all of this is crank science. They say that spherical Earth is crank science. Now, their pedagogical and peer-reviewed approach to understanding the basic features of the climate is this flat Earth approach. The mathematical consequences of it is that the sun must be cold and that it's at twice the distance that it's supposed to be. So think of those two statements, right? So we have two Gödelian incomplete statements working together, right? So they have that the solar input is equal to 1/4 of the solar input. And then they also, by consequence of that, have that the distance between the Earth and the Sun is twice the distance between the Earth and the Sun. So isn't that neat how you get the same sort of inconsistent statements happening now because of their ontologically wrong, uh, empirically wrong flat Earth approach to all this, their globally averaged input of 1/4 solar input, right? So the consequence of that, I mean, if you only have minus 18 degrees Celsius heating from the sun, well, the sun's not going to create any climate at all, is it? That's freezing cold. The sun's not going to create any of your climate. Consequence of that is that you have to invent this greenhouse effect where heat flows from cold to hot to create the climate. Now, heat from cold to hot, that just is thermodynamically ridiculous. That does not happen. If you put an ice cube in your coffee, there will never be a time when you put an ice cube in your coffee and it will heat your coffee. That doesn't happen. If you put ice cubes beside your coffee, they will still not heat your coffee, right? That just does not happen. Everyone understands that, right? But they've actually literally forgotten about that. And I literally argue with them a lot about that point, and because the climate people really believe that that can work, I'm just like, just try it. It doesn't work, but they really think that it might. So anyway, their flat Earth diagram has no day or night. Well, that's not very realistic. It has to be a static flat Earth that's not going to rotate. Mine can rotate. The spherical Earth can rotate. This thing can't rotate. So back radiation causes the lapse rate. So instead of the adiabatic effect causing the lapse rate, they have back radiation causing the lapse rate. My next video is going to get into that. Also covered it in the recent live stream. So the Earth's effective temperature, so the Earth's output, is used as a solar input. I discussed that at length already. And this is peer-reviewed in pedagogical climate science. So this is how climate science is taught at introductory levels. And it also appears in their peer-reviewed literature. Okay, so false initial premises leading to erroneous conclusions, and the erroneous conclusions, as previously discussed, involve their erroneous conclusions, which then inform them what policies they should take. Those policies being, we better block the sun from shining on the Earth, and we better remove carbon dioxide from the atmosphere, when those are actually the basis of life, right? So that's your, solutions having unpredictable consequences, right? Except, I'm predicting them for you now. It's going to be unpredictable to them if they're allowed to go forward with it. So here's the strange thing about this now, okay? So the null hypothesis just means, what if you got it all wrong, basically, right? Resistance to being shown that maybe your theory isn't correct. Now, you think this would be easy to talk to scientists about and show them, right? And of course, if you're familiar with what I've been doing in my books, I detail how I've, researched, did an empirical test with a whole bunch of different physics journals, climate science journals, to see if they would, just appreciate that maybe you can use a sphere for solar input instead of a flat plane Earth for solar input, right? And because the consequence of that is once you acknowledge that, like once you do that and go down that road and start down that road, you pretty quickly and immediately find that, oh, you know what, this whole greenhouse effect hypothesis where CO2 is creating the climate, and it's not the sun that creates the climate, but CO2 creates the climate, all that idea, and global warming, it just falls out really quick. It just quickly becomes not valid anymore, right? But there's extreme resistance, right? So with scientists, you find an infinite resistance. They're infinitely resistant because I've talked with them at years. Again, my book Planet Wars, you saw the result through the peer review system, right? I just spent a week on Facebook debating with scientists, and they're just the most bonkers things you can imagine. I posted this on Facebook to a bunch of scientists, and it's almost like they can't even see the sphere here because they'll start talking about this flat Earth thing down here. And they'll be like, no, that flat Earth thing, that's not a flat Earth, that's a sphere. And I'll be like, well, those are flat lines though, and that input is saying that the solar input is equal to 1/4 of the solar input, and you could only have a totally uniform input if you had a flat plane facing the sun. And they're just like, no, you're wrong. They're like, in fact, your model is more like flat Earth, but this is spherical. Our approach is spherical. Anyway, just who cares about that? It's just Facebook. Maybe I'll link the thread, and you can just read the bonkers, like just bonkers answers. Of course, if you have read my book Planet Wars, you know what my explanation is for why these entities, quote unquote, people are, act like they're basically programmed to or something. So the problem with scientists, they're infinitely resistant to rational and obvious demonstrations that the radiative greenhouse effect is flawed and does not work or exist because of the flawed initial premises, right? That I've been discussing, right? They really, really, really badly want to keep it supported. And they will flat out tell you, as you probably are aware if you've been with me, if you haven't been with me, they will flat out tell you that treating the Earth as a sphere is ridiculous and it's stupid, right? Their approach of using a flat line Earth, they'll say that's totally fine, makes total sense. No, it's totally fine to use a flat Earth for understanding the climate. That's fine. And then I'm like, well, why not just use a sphere? It can be done with a sphere. But they will literally tell you, no, that's ridiculous and retarded. That has no support. They'll be like, that's the stupidest thing I've ever heard to use a sphere. They will literally say things like that to you. It's bonkers, right? It's like, I've had to go through like a decade of gaslighting like that, right? And seriously questioning my sanity until I had support, obviously, from reading the Hockney books, Ontological Mathematics, and just being like, you know what, I'm really going to trust the math here. I'm really going to trust that the Earth is spherical, and I'm really going to trust that it's okay for me to say that the Earth is spherical, right? And you just get these crazy responses from them where they're like, saying that the Earth is a sphere for the climate is the most ridiculous thing ever. So anyway, they really, really, really badly want to keep this greenhouse effect idea supported. They really, really badly want to do it to the extent that they'll say the most ridiculous things to keep it going, right? Now, on the other hand, or on the other side of this, you have policymakers in government, right? And they likewise are infinitely resistant to alternative policy solutions not requiring solar radiation management, meaning blocking out the sun. And geoengineering and stratospheric engineering and biological engineering. They're resistant to any solution which does not involve those, right? So you can see that they're kind of working together, right, to get what? To get this result of blocking out the sun and removing carbon dioxide from the atmosphere. They're really, really resistant to any solutions which show that when they're wrong and it doesn't need to be done, right? So yeah, they really, really badly want to do these things given the radiative greenhouse effect justification that they get from the scientists, right? So de facto, what does this show then? What does it demonstrate? It demonstrates a de facto intent. So what does de facto mean? Describes practices that exist in reality regardless of whether or not they are officially recognized by laws or other formal norms. So what is a de facto intent to? It is like what's it for? Given that that removing sunlight and carbon dioxide from the environment is the number one way to fundamentally destroy almost all life at its basis on planet Earth, ending photosynthesis, where not all sunlight needs to be blocked to get that result, and not all carbon dioxide needs to be removed to get that result, then it's a de facto intent to end all life on Earth in a total extinction level event, because they got the math wrong, because their math is not ontological, because their math does not, the initial premises in their math does not match ontological reality. It does, it sounds so absurd, I know, but it really does reduce to they're doing flat Earth math instead of spherical Earth math. And I'm talking about the initial premises in their approach. Sure, some of them have some spherical climate models, but that's not the point. The point is, where does this idea of the greenhouse effect come from, and the subsequent policy which is attached to that. So the sole origin and reason why a greenhouse effect idea is invented in the first place is because of this, through this flat Earth pedagogy and peer-reviewed literature. That's where it comes from. That's where the radiative greenhouse effect scheme comes from, because it's needed. This greenhouse effect is needed to create the climate, because in their flat Earth math, where the sun is too cold to create the climate because solar input is equal to 1/4 of the solar input, that's a very strong dilution of the solar input, with solar input only being reduced to 1/4 of its power. Yeah, it can't create the climate. So they create a greenhouse effect to create the climate instead. And that's a consequence of the flat Earth theory. Okay. With a spherical Earth, you do not need to postulate a greenhouse effect to create the climate because the sun is strong enough to create the climate itself in the first place with its primary forcing. Okay. So applied ontological mathematics. This is applied ontological mathematics. So the result of this is that we now exist in a state of a real world exercise. Okay, so why is this important? Why have I been going on about this? We now exist in a state of a real world exercise, a real world test of our intelligence as a species with consequences to failure if we fail. Okay, this has gone beyond now the entertainment phase of conjecture and speculation and harmless intrigue by anonymous authors, referring to the ontological mathematics authors. This is now the make it or break it test of this planet's genetic fitness to survive reflected through our intelligence. Okay? Our enemy is going ahead with their plans regardless. We're going to have to stop them by, acknowledging that this is what is happening and then stopping them politically or by whatever means. So this is an ontological mathematics scenario which anyone can comprehend. Flat Earth versus round Earth mathematics. This is very practical ontological mathematics. And the question is, does it make a difference and why? So flat Earth versus round Earth mathematics, does it make a difference and why? That's a pretty simple concept. I think even most people who aren't considered very highly intelligent can comprehend that problem. Is Earth round? Is it flat? Does it make a difference? Yeah, it probably makes a difference, right? So ontological mathematics, IRL, in real life. Okay, so ontological mathematics in real life. So ontological mathematics anchored into planetary consciousness with a few sentences. So that's why this is such a big deal, because ontological mathematics, this whole philosophy of why existence exists in the first place, how it exists, its structure, what our purpose in it, and what we are as humans, and whether or not we have souls, and what is the purpose of our souls. That's the whole philosophy of ontological mathematics. And through this problem of climatological ontological mathematics, this is a vector to get ontological mathematics as a philosophy and concept anchored into planetary consciousness with just a few sentences. And it would work as simple as this. They almost destroyed all life on Earth because they did flat Earth math. The Earth isn't flat, it's round. If you use round Earth math, then you don't make the mistakes which would have killed everything. Okay? That's 3 sentences which are 100% about applied, practical, ontological mathematics. And that is an anchor for the concept of ontological mathematics to exist, on this planet in society as a whole, society-wide, planet-wide, or at least in whatever culture is going to appreciate it, right? So they almost destroyed all life on Earth because they did flat Earth math. The Earth isn't flat, it's round. If you use round Earth math, then you don't make the mistakes and conclusions which would have killed everything, which would have led to you killing everything by mistake, right? That's a great way to anchor ontological mathematics onto this planet, right? And that is what's happening. This is the real world test. If we fail, if they're able to go ahead with their plans, there's going to be a mass extinction level event which will end all life on Earth because they're genetically engineering bacteria that when released into the air will consume, the bacteria. I don't know if you have the idea of bacteria in a petri dish. What happens? The bacteria consume all the food available in the petri dish until there's no food left, and then they die, right? And there's no food left in the petri dish. So if you've genetically engineered bacteria to live off of carbon dioxide instead of sugar or whatever else they might eat, you've genetically engineered them to live off carbon dioxide, and you put that out into the atmosphere. Now the atmosphere becomes the petri dish, and this bacteria will exponentially replicate until when? Until it consumes all of its food source. The food source being free carbon dioxide in the air. The end result of that is no more carbon dioxide in the air, and the end result of that is no more photosynthesis and no more life on Earth, on the surface of the Earth, okay? That is the end of life, okay? And they are genetically engineering bacteria to do that. They're also coming up with devices like big industrial plants that are literally like a vacuum type of thing. Just these great big air suckers, like huge industrial air suckers. They just turn on and they suck in the air and they remove carbon dioxide en masse from the atmosphere. Okay, so if you just turn that device on and left it running, eventually it would just take out all the carbon dioxide from the air. And you don't have to remove all the carbon dioxide. You only have to remove, I think it's like 50% of what we have now or thereabouts. And you would end all life on Earth. Photosynthesis would stop. Okay. So again, I want to make a request to you guys now. Support this work, please. Okay, there's my Bitcoin address if you can scan that. Otherwise, there's the numeric alphanumeric address. So I'm the only one doing this work right now at this level, right? Now imagine if I had some production quality, right? I'm showing some really simple things, right? Imagine some production quality behind this. There's a lot of really simple graphics and very nice graphics that could be created to demonstrate all of these ideas. These are simple ideas that I'm demonstrating here about practical ontological mathematics, right? Some production quality would be awesome because some people really respond to that. I mean, for me, I can watch something with zero production quality and I appreciate the content and what the person is saying, right? Even books. I can read extremely poorly written books, but appreciate the concepts being shared and then go with that. Other people need production quality, and that's the only thing that would make a difference for them, right? So production quality, how do we get production quality? Well, I'm going to need some support for that for sure. So I'd really appreciate, guys, that'd be awesome. So I do have a PayPal. I think you can send up regular payments through PayPal if you like, paypal.me/Joe Postma. I'm also have givesendtogo.com/ontological mathematics. So the idea with this thing is to develop a whole new curriculum with ontological mathematics. The form of the good from Plato, the philosophical idea of the form of the good, principles embedded in the education from the start, high IQ, no woke perversions, no secrets kept from parents, no critical theories, just real proper traditional education as education is supposed to be, right? And of course, the other thing would be to redevelop and interpret and reperform the relativity and quantum mechanics thought experiments and experiments, as I sort of outlined in one of my recent books, which is actually right here, Debunking the Simultaneity Paradox and Solving the Double Slit Experiment. Okay, so I could really, really use your support to keep this work going. I'm the only one doing it at about this level and with all the connections that I'm making with ontological mathematics and the philosophical importance and the consequences. There's a few other people that are doing it at about around near this level. I think who's a fellow? I think Robert Ian Holmes. I think does very good work, and there's a few others that are totally on board. I should actually have a meeting with them. We should have some sort of a yeah, that'd be great. Either live stream or pre-recorded or something, meeting with those guys just to talk about this and demonstrate the real science. In any case, as for me personally, I could really use your help and your support. Your support would help improve the production quality. We could make some slick videos, some slick ads. Even a simple documentary. Obviously, you need some, enough funding to get people. I don't do that. I guess I could read and figure it out and do the research and learning myself to get to do the production quality. But if you could just outsource that would really, really help, right? And, pay for it, pay for the people just to, I'll give them the basic idea, show what it's all about, and then get a very, very nice, slick documentary or something made on this to educate people, because anyone can understand this. If it was simply demonstrated to them with some slick graphics, that would take off and be viral very, very quickly, and there would be nothing that the liars and the parasites who are here trying to destroy the world would be able to do against it. Okay, and then of course my books. If you are not familiar with them or haven't read them all yet, here they all are. You can go to my author page there. I'll have this presentation as a set of PDF slides in a PDF document in the description. All right, so there you go. That's why ontological mathematics is important in climate science. Ontological mathematics is not simply about speculation and navel gazing and impractical things to do with why does exist. I mean, that's practical. Why does something exist rather than nothing? Sure, that's a practical question. On the other hand, a lot of people would consider it not too practical in the day-to-day. However, on this climate science issue, I mean, ontological mathematics absolutely applies practically to the real world at every moment and in every facet of our life. And yeah, absolutely to the climate. Getting your math wrong for your initial premises on the climate leads to really wrong conclusions. And why is the math wrong? Because it's not ontological, because it does not match what reality actually looks like and exists as, right? So if you get that correct versus incorrect, you get totally different conclusions, totally different results. If you get it wrong, you know, so far in our civilization, getting the math wrong, right, doing non-ontological math hasn't been that consequential, right? We've now arrived at a subject where getting the math wrong, okay, in climate science leads to very consequential results. Very, very consequential results, you know? And sure, I can't say that's never happened. Sure, I mean, engineers have gotten the math wrong before and, you know, caused accidents, things to fall apart while people were using them and hurt people. Yeah, sure. So that happens, right? On a small scale, individual scale, you know, things like that. But now this is a very, very large scale, planetary wide problem and an example of getting the math wrong, of doing non-ontological mathematics and getting therefore led to false conclusions about what you should do, right? The policy that comes out of it. In this case, they're making a very, very big mistake. They want to remove sunlight and they want to remove carbon dioxide when those are actually the basis of life on Earth. So we're getting it wrong and going ahead with the solutions based on all this false premises. These are, you know, solutions based on that. So they're the wrong, or the solution. This is the wrong solution to do. But if they go ahead with it, they're going to end all life on Earth. So this is we've come as a civilization to an example where getting the ontological mathematics correct, or getting the mathematics correct, getting it ontological, getting it to match reality is very, very important. Perhaps this is a threshold. This is a threshold that a species has to get through. Does a species survive this first reckoning with planetary scale consequences of ontological mathematics, where if we get it wrong, we destroy ourselves, right? If we get it right, we survive. And that, you know, sort of graduates us to a new level of reason and rationality and responsibility in the universe is something. It's kind of neat to think about. Anyway, it's real. It's going to happen if they are able to go ahead and with their plans of what they're planning, genetically engineering bacteria, creating machines to suck all the CO2 out of the air. They want to put a great big space umbrella in space between Earth and the sun to block out the sun because they think that's what they need to do to stop the Earth from warming up when it's not even freaking warming. It's not happening at all. That's not even a problem that exists. But they're going to create all these solutions that will, they think it's going to be good for the environment because they're so wound up in this, right? When if you just step back and you can see and know those things are actually really, really bad for the environment. And in fact, they're so bad, you're going to kill the whole environment, right? So that's what we're facing, and it's going to happen if we don't stop it. So please support me and support me to continue doing this. So in any case, I hope you enjoyed that, and I hope you all have a good day wherever you are. Take care. Bye.